Hello everybody, welcome to new video in which we are going to deploy our machine learning or you can say deep learning model using Flask framework. So obviously we are going to use Python language and Flask module. If you haven't installed Flask, so you can say pip install Flask, and also we are going to use OpenCV and NumPy array and all those basic packages, you know that. So this video is more probably you can say is the continuation to part 1 of automated image captioning. But don't worry, if you have another deep learning model and you want to deploy it on web app, then you can follow along this video and I will tell you where the things you have to change so that you can use as your model. So this is a sneak peek to what at the end of this video you will be able to make. So if we pass in the image, it will predict the caption for the image. And if you want to follow along with this video, if you want to create this project, then you can go in below description and you will come to this Kaggle notebook link. You can come over here and go to output section. From there, then you should see this mindmodelweights.h5 file. So you can click on this little download icon. Once you click on this, you will download a weight file. Let me just show you. So this will be the file which you will be able to download once you click the play button. Alright, so once everything is done, let's start the video. Okay, so I will divide this video in some steps so that you may not confuse in between the videos. I will also include the chapter or you can say timestamps for the video. So first of all, we will have to create a folder structure. So let's just first create that. So let's first create a folder name of your choice. So I will say image caption. And once we get in this folder, you will have to create a new Python file. Let's name this app.py. Okay, so this is the app.py name. And after that, you will have to create a new folder named templates. And in that, let's create new HTML files. Let's say first is index.html and the another is predict.html. Make sure it is named as templates. If there is even simple spelling mistake, this will not going to work. And let me tell you what index.html is. This is the front page to the user, using which user will transfer the values or pass in the image, whatever your functionality of the model. And predict.html is the next page similar to this one, predict.html. This page is basically it will show the user the output of the previous input given to the index.html. Okay, and this app.py is something where we are going to code everything. Now let's just create one more folder. Let's say static. We will not include anything in there, but you can include your CSS styling files or bootstrap styling or whatever you want to. But for now, we will just leave this as empty. And let's just place this downloaded model weights to this folder and let's just open this with VS Code. Alright, so once you are over here, you can use any ID you want, but I'm going to use VS Code for this purpose. Alright, so once you are over here and you have installed every framework named Flask, CV2, and obviously the framework like keras if you are using deep learning model, sklearn if you are using machine learning model, or you know it. Okay, so first of all, we will start by importing Flask module. So we can name this timestamp as like creating a basic structure for our app. So we can say first of all from Flask import Flask. Let me just get rid of this space, and we are also going to use render template. Alright, so once we have done that, we will create our app named as app is equals to Flask, and in this we will pass in __ name. And another last thing you have to say, if name is equals to main, we will say app.run, and we will set debug equals to true. Setting debug equals to true, it means whenever we make any changes in app.py, it will going to directly make changes in our local host or wherever we are running this app. Alright, so this is the basic structure for our web app. So now we will go further. We will create a structure where on the index, or you can say index.html, we will have a button. Once user presses that button, it will going to take us to predict.html. So let's create that. So on the index.html, we will create a form first of all, and in the action we will set URL for, and in the URL let's just pass after. Okay, and also we will give this a method, but by default it is a post, so we will not give. By default it is a get, so we don't need to give this. And in that, let's create a button, submit button, and let's go to app.py, and in that create a route, and this will be the base route. So in this let's create a function called index, and it will going to return render template. Render template, it means it will going to render the HTML file, and in this we will pass index.html. Let's create another route, app dot route slash after, and make sure this after correctly spells according to this after. And let's in this create a function called again after, and this is also going to return render template, but this time predict.html. Okay, let's do one thing in the predict.html. Let's say you are at predict. Okay, so it looks like everything should work fine. Let's run this. So you can run this by saying python app.py. Okay, so this is running at 127 localhost. Let's refresh this and we have button. Let's press on this button and it takes us to next page. You are at predict. All right, so this is our basic structure. Now let's move one step further, and now we will let the user select a file, and it will going to save that image file to this static folder. So in the index.html, we will create an input type of a file, and we will give this a name of, let's say, file1. And in this we have to pass encoding type equals to multi-part form data, because we have to transfer the file this time, not only the text data. All right, now we also have to import a module called request from the flask, and in the after function we can say file equals to request.files, and in this we can pass in the name of this field, which is file1. And let's do one thing, let's just save this file. We can say file.save, and we can save this in static folder. All right, so let's just test this. Let's go back, refresh this. So this time we have choose file option, and let's just choose this file and press submit, and we got an error, which is bad request key error. I guess in this we have to give method equals to get and post. All right, so it is working now. We just have to pass in the methods. Let's go in the folder and let's see over here we got our file.jpg. So the problem was we have to give post method, and in this after route we also have to pass in this methods list. All right, so now let's do one more thing, and that thing is kind of obvious. We have to say app.config said file max age default equals to 1. This is because Chrome will always, or the browser you choose will always going to use cached images. So if we set this to true, it means it will going to refresh the image every time we refresh the page or transfer the file every time. So let's do one thing. In the predict.html, once the user chooses the image, let's just show the user the image he chose or she chose the image. So it is really easy. We can say img source equals to, and this time also we have to choose URL for, but this time we will use this URL for in order to choose the image or find the image. So we can say URL for file name equals to, obviously we saved it by using file.jpg, and folder name is static. Let's save this and refresh this and see if this works or not. Okay, so this is the image. Let's choose another image. This is the image. All right, so everything is working fine. Now let's come to the next part, where we have to load the model and we have to make the predictions according to the user input. Well, this is really easy, and the things go in the same order, where when you do without using the Flask framework or without using the web apps. So we just have to say model.predict if you have simple machine learning model, but if you have complex deep learning model, you will have to also have to apply image preprocessing if you are using image data. So that's kind of similar, and we all have to do this in after function. So in our case, we have our deep learning model, which we have built using keras. So let's just first import all the dependencies. Let's save this and paste it over here, and these are the packages. Okay, so we will come back to this Kaggle notebook, go into notebook section, and in our model, as we have saved the weights, not the model, so we have to again create the model and we will load the weights. Okay, let's just copy this particular model in this way. Let's copy this and take two over here. This might be different for your case if you are using different model. Let's get rid of printing the summary of the model. All right, now over here we can say model.load. Okay, so this will going to load our model, and that's not the only thing you have to do. Actually, we also have to load the dictionary, and we also have to set the max length, which is 40 in this case. Okay, so everybody, now we have to load our vocabulary. So in our output section, we also have vocab.npy. Okay, so just click on this and download this. It's around 75 kilobytes. I have already downloaded, so I will take this from here and take to the folder over here. Now we will just load in our code. Again, this section is kind of confusing if you are using different model, but if you are using same model, this might be really you have to just follow along with this code. So we can say vocab is equals to np.load, because we have saved it using numpy, and actually we have to pass in these parameters, mine vocabulary.npy and allow pickle equals to 2. So once you run this, we will have our vocabulary, and in this we can say vocab size equals to length of vocab. Okay, and now we will create inverse vocabulary. Again, it is really easy. We can do this in single line. That's the power of Python. We will set key as a value and value as a key. That's it. And now we have our vocabulary ready. Now we have our model ready. Now we just have to say model.predict. But that's not all we have to do. Actually, we also have to apply image preprocessing. And as this is a complex model, we also have to create a specific inference model for this model. So we have to apply all these functions like adding start of sequence token and then running true loop, or you can say loop up to 25 length. All of this I have explained in part 1, and if it really confuses you, you can go to part 1 and learn how I created this model and all this stuff. Okay, so now what we will do in our after function, we will come over here and we will have to say global model and vocab and at last resnet. Not actually resnet, not now, I will talk about it in a bit. Okay, so model, vocab and inverse vocab. Now quickly I will explain you. If you remember, in part 1 we have used resnet in order to pre-process our image, or we used resnet to extract the features from the image. So this time again we have to do the same thing. So we have to import resnet model, but I have already downloaded the resnet model, so I will just take this from over here. I will also explain you, if you haven't downloaded the resnet model, what you have to do. So if you haven't downloaded the resnet model, you have to paste this line from keras.applications import resnet 50. Again, I have explained this in part 1. You have to write this line and you can say resnet is equals to, so you can say resnet is equals to this line, huge line. So you can say resnet is equals to resnet 50, which we have imported from keras.applications. Include top equals to false. Again, I have explained this in part 1, because we don't want to predict the classes, we just want to extract the features, so we'll get rid of the last layer. And weights we are going to use is from ImageNet dataset, and input shape this 224 and 3 color channels, and pooling equals to average. So you have to do this if you haven't downloaded the model, but I have downloaded the model. Actually, I just comment these lines. So if you haven't downloaded the model, so if you have already downloaded model, you can say model is equals to load model resnet.h5, and obviously you have to import from keras.models, import load model. All right, now everything is fine. Now we have our all the model ready to just make the prediction and just pass into predict function. All right, so now let's just make the prediction and transfer it to predict.html page. Also we have to over here say resnet. Instead of model, we will say resnet, because we have already one model variable named over here. All right, everybody, now let's just actually confirm if everything is working fine or not. Okay, so we will just make print statements into 50, and we can say print. Let's just copy so that we can know if resnet model or this model has been loaded or not successfully. So let's just save this and run our app. This time it should take some time to start. Okay, so we got an error which is mine vocab.npy is not available. It is vocab.npy. Actually, I think I have copied wrong file. Image captions. Yeah, I have to copy this one. Okay, we got once again, which is no attribute items. Okay, I think we have to say vocab equals to vocab.items. because this is a numpy array, we have to use dot items to get original variable, which in this case it's a dictionary. Okay, we got an error, has no attribute items. Actually it is item, not items. Yeah, it is item. Let's CLS. Okay, so it says resnet loaded and model loaded. So now everything is working fine. Now we just have to make the predictions. Alright, so let's come over here and we just have to apply some image pre-processing, which is required for our model. We can say img equals to cv2.imread, and in this we can pass obviously static slash file.jpg. This is the image. Now we have to convert this to RGB format, cv2.cvt. That we are doing this just because cv2 reads the image in BGR format. We just have to change this to RGB format. Okay, so now we have to resize this image by using cv2.resize image to 224, 224, and now we have to convert this to batch size, batches actually, batch of one image. So we can say np.reshape this time, and we can pass in this image now size, which is one batch size, 224 height, 224 width, and 3 color channels. Alright, so now with this head, now we just have to say features, or you can say image features if you want. You can say resnet dot predict on image dot, and we will reshape this to 1,2048 values, means one batch size and 2048 values. Okay, so now we have the image. Now we just have to create a start of sequence token. So this is the text input, and final variable will be used for holding the final caption. Actually, let's just make a print statement so that we know it is creating captions, and that's the last thing. You just have to do count equals to 0, and we'll increment it every time once the loop passes, and we will check if this is less than greater than 20. We will get rid of this to loop or while loop. And in this is encoded, and I just explained all of these things in the previous part. These are not just really complex things. You can just know about them if you just sit, relax, and just start to understanding these things. What we are doing, we have our string of text in, so we will have to convert them to integer so that we can make prediction from our model. And we used encoded list, and we iterated in text in, and we used vocabulary to convert string to word. Then over here we used inverse vocabulary to convert predicted integer to convert back to what we call that string or corresponding word. Okay, so we use pad sequence to create a max length of 40, so that every time we pass in constant length. And over here we are getting a error. We have to pass this as feature. This is the name of the image, or you can say feature of the image, and this is the padded. So if you know the structure of our model, let me just show you quickly. Okay, so this is our model. We have to pass in the what we call input text sequence and this image input, and in return it gives us probability of 4011 words. Okay, it means what word has been predicted. So I have explained all this in part 1. If you need better understanding, you can go to part 1. Okay, so now it seems like everything should work fine, and this is our final caption. As you can see over here, we are incrementing it every time. Let's just pass this to next page by saying final equals to final. You pass in the data to next page by using this syntax. So this is the variable name with which you can use in next variable or next HTML pages, and you can show user the data by using these two curly braces and just passing in the name of the variable. So let's start. It seems like everything should be working fine. It says running at 127. Let's come in over here, refresh the page, hopefully choose the image, submit. Hopefully it should make the prediction in case if we not get any error. So it says getting captions. So it received the caption, I guess. Yeah, it says a little girl in pink dress sit in front of large rainbow. Alright, so this is the final web app. Now obviously you can use Bootstrap, you can use CSS to apply the styling. If you want the styling which I showed you earlier in the part of the video, you can go in below description and check out the code. And with this said, I would like to stop the video, and if you haven't yet subscribed to my channel, make sure you subscribe and give this video a thumb up to keep me motivated and keep me creating new videos for you.